So till now we have studied about two types of finite automata, that was the non-deterministic finite automata and deterministic finite automata. But now we will be going to study two models of finite automata, that is the Mealy machine model and Moore machine model. There is a major difference between two models. Also, in the previous classes we have studied about acceptability of a string on finite automata. We were given a string and we checked if it is acceptable to a DFA or an NDFA or not. But now we will not check the acceptability, we will get the output from a finite automata. That means these two machines will give us the output for that strings that will be acceptable. Now we will not check, we will not give the binary decision of yes or no. Now we will get the output. These outputs will be automatically accepted by both the models, Mealy machine model and Moore machine model. So come, let's begin it now. Now in the Mealy machine model of finite automata, our output is dependent on the present state as well as the input symbol. This is the output function. It is dependent on present state as well as the input symbol. That means whenever the machine is one state and when an input symbol is applied on that state, it will move to another state. This is how this statement is read. This is the output function that denotes what kind of output we will be going to get. So output is dependent on the present state as well as input symbol applied. But in case of Moore machine, our output function is dependent only on the present state. That means whatever the input is given to the machine, it will only check the state of the machine and take the next move according to this state only. It will not check the input symbol. This is the major difference between Mealy and Moore machines. Now we will be going to discuss their analytical definitions and then see their examples. Now let's study the definition of Mealy machine first. In Mealy machine we studied that the output is dependent on the present state as well as the input symbol. The analytical definition states that it is a 6-tuple automata. 6 tuples are Q, sigma, triangle, delta, lambda, Q naught. Q is the finite set of states we already know. This sigma is the input alphabet, that means the set from which input symbols would be taken. This triangle is the output alphabet, that means whenever a machine is in one state and applying the input symbol, it moves to another state, and moving to another state simultaneously it produces an output also. That output will be also in the form of symbols. Those symbols will be elements of this output alphabet. The output symbols will be the elements of this output alphabet. Delta is the transition function. On applying input symbol to a state, the machine will move to another state. This lambda is the output function, this one, it is the output function. That means on applying input symbol to a state, the machine will also produce an output, and in the output there are symbols. Those symbols are element of this triangle output alphabet. This Q naught is the initial state. Q naught belongs to Q, this we already know. Now we see the example of a Mealy machine. This is the transition table for a Mealy machine. Now in case of Mealy machines or Moore machines, we don't have any final state. Why? Because we don't have to move from initial state to a final state and check the acceptability of a string. Only thing is we have to produce the output. So we start from the initial state only. And then there are two input symbols, 0 and 1. They are represented by A. And for each input symbol, the column is divided into two parts, state and output. Here also state and output. Now let's read this transition table. The present state is Q1, initial state. Q1 on applying 0 will move to Q3 and produce 0 as output. Q2 on applying 0 will move to Q1 and produce 1 as output. Q3 on applying 0 will move to Q2 and produce 1 as output. Q4 on applying 0 will remain to Q4 and produce 1 as output. That means the output is 0 or 1 only. That means the output alphabet will contain the symbols 0 and 1. And for 1, input symbol as 1, Q1 on applying input as 1 moves to state Q2 and produces 0 as output. Q2 on applying input symbol 1 moves to state Q4 and produces 0 as output. Q3 on applying input symbol as 1 moves to state Q1 and produces 1 as output. Q4 on applying 1 as input symbol moves to state Q3 and produces 0 as output. So this is the transition table for a Mealy machine. This is how it looks like. We will see it in our later examples. Now first let's consider the analytical definition of a Moore machine and see its transition table also. Now let's discuss the definition of a Moore machine. In the case of Moore machine, we stated that output depends only on the present state. This is the output functions which depend only on the present state. Also, Moore machine is a 6-tuple automata: Q, sigma, triangle, delta, lambda and Q naught. Q is the finite set of states. Sigma is the input alphabet, that means the set from which we will take the input symbols. This triangle is the output alphabet, that means the machine will produce some or the other output, and those output will be having some symbols. Those symbols will be present in this set called the output alphabet. Delta is the transition function, that means on applying input symbol from this input alphabet on a state, the machine will move to another state. Lambda, it is the output functions. In the case of Moore machines, output is only dependent on the present state. Therefore, any of the state will produce some or the other output. That output will be consisting of symbols. Those symbols are a part of this output alphabet. This is the meaning of this Q maps to delta. In case of Mealy machines, it was sigma cross Q maps to delta, because the output was dependent on input symbol also, but here it is dependent only on the state, so sigma is not included. Q maps to delta only. Q naught is the initial state. Now we will study the transition table for this Moore machine, and it will be clear to you what is the major difference between Mealy and Moore machines on seeing that transition table. Now this is the transition table for a Moore machine. See here, this is the column for present state. These are the two input symbols 0 and 1, and there is the output. In comparison to a Mealy machine, for each input symbol there were two columns, state and output. For one also it was state and output, but here there is only one single column of output and two columns of states for each of the input symbols. That means Q naught on applying 0 will move to Q3, and on applying 1 it will move to Q1. But output is independent of both these input symbols 0 or 1. Whatever the input symbol is, either it is 0 or it is 1, it has to be produced output as 0. That means it is dependent only on the present state. Present state is Q naught, then output will be 0. If present state is Q1, output will be 1. If present state is Q2, output will be 0. If present state is Q3, output will be 0. So it is only dependent on the present state. It is not varying according to the input symbol. This is the major difference between a Moore machine and a Mealy machine. So let's read this. Q naught on 0 moves to Q3, Q1 on 0 moves to Q1, Q2 on 0 moves to Q2, that means it remains there only. Q3 on 0 moves to Q3, that means it also remains there. Q1 on 1 moves to Q naught on 1 moves to Q1, Q1 on 1 moves to Q2, Q2 on 1 moves to Q3, and Q3 on 1 moves to Q naught. And these are the present state. Depending on these present state, this is the output produced by the Moore machine. So output is having symbols 0 and 1 only. So triangle will be a set of output alphabet. This will also have 0 and 1. Sigma is also 0 and 1 input symbols, and the set of states is Q naught, Q1, Q2 and Q3. So this is the Moore machine's transition table. Suppose this is the Moore machine given to us. The transition table of a Moore machine is given, and we have to produce the output. We have to see how a Moore machine produces the output. The question is, produce the output if the input given as 0, 1, 0, 1, 1. A string is given as input to this Moore machine, and we have to calculate the output. So we always start with initial state. Present state is Q naught, and assume that we have switched on the machine, but we have not yet fed this input to the machine. We have not yet given the input. Then no symbol will be scanned, that is null move will be there. Q naught on null will give the output 0. This is the property of a Moore machine, that whenever you switch on the machine, and initial state we have to consider, and at initial state the output will always be 0. This is the property. We always have to include this null move and the output 0. Now let's start with the initial state Q naught. Now output is, the input is given 0, 1, 0, 1, 1. The string is fed to the machine now. So again we start with the initial state. Q naught on scanning this first 0, the symbol scanned is 0. Q naught on scanning 0 will move to state Q3 and produce 0 as output. So output produced is 0, and state we have moved is Q3. We have moved to state Q3. So now present state is Q3. Now on Q3 we apply this 1 as input, next symbol 1. Q3 on 1 gives us Q0 and 0 as output. So we scan the symbol 1 and output produced is 0, and we are again moved to Q0. Now we are at Q0. Now present state is again Q0. Now Q0 on application of this 0, Q0 on application of 0 will move to Q3 and produce 0 as output. So symbol scanned is 0, output produces 0, and we again move to Q3. Now present state is Q3 again. We come to Q3 and scan this 1. Q3 on scanning this 1 moves to Q0. On scanning 1 it moves to Q0. Q3 on scanning 1 moves to Q0 and produces output as 0. So now we are again at Q0. We scan present state Q0 again, and applying this last one, Q0 on applying 1 moves to state Q1 and produces the output as 0 on the last one. So output is 0 0 0 0 0 0. So on scanning this input string, our output produces 6 zeros. So this is how a Moore machine produces the output. Let's consider one more example. Now this is another example. We have to scan this string and produce the output for this Moore machine. So first move is always Q0 null 0 from the initial state. Now consider the string on applying the state Q0 with the input symbol 1. Q0 on 1 will move to Q1 and produce output as 0. So it produced output as 0 and moved to Q1. Now our present state is Q1. Q1 on applying this one, Q1 on applying this one moves to Q2 and produces the output as 1. Q1 on applying 1 produces the output 1 and moves to Q2. Q2 is our present state now. Q2 on applying this third one, Q2 on applying 1 will move to Q3 and produce output as 1. Q2 on applying third one will produce output as 1 and move to Q3. Now our present state is Q3. Q3 on 0. Q3 on applying 0 remains to Q3 and produces output as 0. It remains to Q3. Now full screen string has been scanned, so the output is 0 0 1 1 0. 0 0 1 1 0. This is our output for this Moore machine. Let's consider one more example. Now in this question we are given a string 0 1 1 0 and we have to find the output for this Moore machine. So first statement Q0 null and 0 output. Then we start again from our initial state Q0. On applying this 0, Q0 on applying this 0 moves to state Q3 and gives the output 1. So output is 1 and next state is Q3. On applying 0, output is 1 and next state is Q3. So Q3 will become our present state. Q3 on applying this 1. Q3 on applying this 1 moves to state Q0 and produces the output 1. Q3 on applying 1 produces the output 1 and moves to state Q0. And now our present state is Q0. Q0 on applying this 1, Q0 on 1 will move to Q1 and produce output as 1. So output is 1 and next state is Q1. On 1, output is 1 and next state is Q1. Present state will become Q1 now. Q1 on applying this third one, Q1 on 1 will give us Q2 and output as 1. So output is 1 and next state is Q2. On applying 1, output is 1 and next state is Q2. This Q2 will be our present state now. Q2 on applying this 0, Q2 on applying 0 will remain to Q2 and produce 0 output. So output is 0 and state is Q2. On applying 0, output is 0 and state is Q2. Now full string is processed. So our output is 0 1 1 1 1 0. Output is 0 1 1 1 1 0. This is our output for this input given to the machine. So I hope production of output from the given input string to a Moore machine is now clear to you. Now we will see production of output from a Mealy machine. Now let's see one example for Mealy machine. This is the input string which is given to this Mealy machine and this is the transition table. For each of the input symbol there are two columns, state and output. That means input symbol is also a major entity for the output in the case of Mealy machine. So let's start. Suppose we have switched on the machine and have not yet given the input to it, then present state will be Q0, initial state, symbol scanned is null, the output will be null in this case. Now this is a point to be noted. In case of Moore machine, when no symbol was scanned, the output was 0, but in case of Mealy machine, the output is null in case no symbol is scanned. Why? Because in case of Moore machine, the output is ready to be shifted, but in case of Mealy machine, there can be no output till the time no input symbol is applied, because output is dependent on the input symbol. Till the time there is no input, there will be no output. So in case of Mealy machine, output will be null in the first statement, but in case of Moore, it will be 0. Then we start with the initial state Q0. Q0 on applying this 1, Q0 on applying 1, here is 1, will move to state Q1 and produce output 0. So output produced is 0 and state moved is Q1. On applying 1, output produces 0 and state moves is Q1. Now present state is Q1. Q1 on applying this 1, Q1 on applying 1 will move to Q3 and output is 0. On applying this 1, output is 0 and state is Q3. On applying 1, output is 0 and state is Q3. Now present state is Q3. Q3 with the 0. Q3 on applying 0 remain to Q3 and produce output as 1. So on 0, output produced is 1 and state is Q3 only. Next state, present state is also Q3. Q3 on this 0, Q3 on this 0 produces 1 as output and remains to Q3. On 0 produces 1 as output and remains to Q3. So we have got the output null 0 0 1 1. We have not to take the null, it is one and the same thing. So output is 0 0 1 1. So major point of concentration was this statement. In case of Mealy machine, we have null output for the initial switching on the machine because no input is scanned. If no input, then no output. In case of Moore machine, if no input, then output was 0. So this is how a Mealy machine produces the output. Now let's see one more example. Now we have to check for this input string. On applying this input string, what does this Mealy machine produces the output? Now I want you to note these questions also in your notebook and along with the answers, as I am changing the questions every time. This is not the previous one. So 0 0 1 0. First move Q0 on the symbol null, output null. Then we start again from initial state Q0. Q0 on applying this 0, Q0 on applying 0 moves to state Q2 and produces output as 1. That on 0 it produces output as 1 and state is Q2. So our present state is now Q2. Q2 on this 0, Q2 on 0 moves to state Q1 and produces 0. Q2 and 0 produces output 0 and moves to state Q1. So our present state is Q1. Now Q1 on this one, Q1 on the 1, Q1 on input symbol 1 moves to state Q3. On input symbol 1, it moves to state Q3 and produces the output as 0. Now present state is Q3. Q3 on this last 0, Q3 on 0 remains to Q3. Q3 on 0 remains to Q3 and produces output as 1. So our output is 1 0 0 1. Null is ignored. Output is 1 0 0 1. Let's consider one more example. Now let's see this example of a Mealy machine. We have to check for this string on acceptability of this transition table of Mealy machine. So first move is Q0 null null. Then we start from initial state Q0 and Q0 on seeing this one, Q0 on input as 1 will move to Q3 and produce 0 as output. On seeing 1, it will produce 0 as output and move to state Q3. So our present state is now Q3. Q3 on seeing this 0, Q3 on seeing this 0 remains to Q3 and produces output as 1. So on seeing a 0, it produces output as 1 and remains to Q3. So again present state is Q3. Q3 on seeing this 0, Q3 on 0 will produce same thing, Q3 on 0 will produce output as 1 and remain to Q3. Q3 on this 1, again present state is Q3, Q3 on 1 will go to Q2 and produce 1 as output. Q3 on 1 will produce 1 as output and go to Q2. Then our present state is Q2. Now again 0, Q2 on 0 gives Q1 and output as 1. Output is 1 on 0 and goes to Q1. So whole string is processed and the output collected is 0, 1, 1, 1, 1. So I hope so. Production of output on Mealy machines and Moore machines is now clear to you. Now in our next video we will discuss about interconversion of Mealy to Moore and Moore to Mealy. So I hope you have cleared your concepts about how a string is produced as an output on Moore machine and a Mealy machine, and you have understood the difference between Moore and Mealy machines. Now if you have any doubt, you can comment in the video section or just drop an email at the email address mentioned in the description of the video. To go to our latest update, please find on the screen, and to go to our playlist also, please find on the screen. And if you have not subscribed to our channel, please hit the subscribe button also. Thank you.